Hey Internet, welcome to heat transfer tutorial. This is a made up question not found in your textbooks. So we've got an aluminium sphere. Its initial temperature is 81 degrees Celsius, so it's preheated. And then the final temperature on average is 201 degrees Celsius. The density of aluminium at this temperature range is 2,700 kilograms per meter cube, and its specific heat capacity is 0.90 kilojoules per kilogram per Kelvin. We want to find the energy required to achieve this temperature, otherwise known as the energy transfer. Okay, so step 1, draw your free body diagram, your FBD. This will help you visualize the problem. So energy is going in, being transferred into the sphere or ball, and we want to find this energy. Step 2, list all the given variables, find the unknown. So the sphere is 16 centimeters in diameter. Okay, and everything else has been stated previously. What we're trying to find is the energy transfer, so capital E. Okay, so step 3, find the energy transfer formula. So energy transfer is equal to delta U, delta being change, and U is the internal energy. So we're going to expand delta U, and it will become E is equal to M, which is mass, multiplied by Cp, which is the specific heat capacity, with respect to constant pressure in this case. Okay, and then we've got the change in temperatures as well. T2 is going to be T final, and T1 is going to be T initial. T represents temperature. So they give us the temperatures and the specific heat capacity. Okay, so that means we're missing mass. So step 4, find the mass formula. It is M is equal to rho multiplied by V. So the Greek symbol rho is for density. So they have given us the density, as you can see, 2,700 kilograms per meter cube for aluminium, also stated in the question. Alright, so in this formula, we're missing volume. They do give us the diameter of the sphere, so we can work out the volume of a sphere. So that's the next step. Step 5, find the volume formula. So since they stated it's a sphere, the volume of a sphere is pi divided by 6 multiplied by diameter cubed. Step 6, we plug and play to find the volume. So for the diameter, we're going to convert centimeters into meters by dividing by 100. We want it to be in meters so we can cancel out units later on. So our volume is 0.002145 meters cubed. We can now backtrack. Step 7, find the mass. So we'll get 5.7915 kilograms. Step 8, now we can fully backtrack and find the energy transfer. So now that we found mass, we can just plug in everything else. So the units will cancel out and we will be left with kilojoules. So it will be 625.48 kilojoules for the energy transferred to the aluminium sphere. So this is the amount of energy required to reach this temperature. Disclaimers: the method is correct, however, I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answer. Now, before we leave, I highly recommend that you save this video onto your PC just in case this video or channel gets taken down. While I follow all copyright laws, sometimes things happen. If you're on a Mac, use the Mac equivalent of snipping tool. If you never used snipping tool before, follow these instructions. Click on the icon in your taskbar. If it's not in your taskbar, go to your Windows search, type in snipping tool, open up the program, click on video option, click on new, left click and drag the rectangle to cover the YouTube screen. This is just an example. Hit the start button in snipping tool, wait for the countdown, hit the replay button on YouTube, let the video finish, and then hit the red square in snipping tool to stop recording, and then save your video. Thanks for watching. Like and subscribe. Share with your friends because this is a made up question, so they probably won't be able to find it. If you got questions, comments, or if you find a mistake in the video, leave it in the comment section. I'll get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.